Hello everyone. On this video we will be covering solving quadratic inequalities. Okay, so to do that we're going to start off with a little reminder as to what an inequality is. An inequality is just your less than, greater than, less than or equal to, or greater than or equal to. Those are inequalities. And the quadratic inequalities is just your quadratic expression. And instead of an equal to 0, it's just less than, greater than, less than or equal to, or greater than or equal to 0. Okay, let me try to focus this a little bit. There we go. Okay, so now we're going to go ahead and go through the steps for solving quadratic inequalities. Slide that up a little bit. There we go. Okay, so your first step is you want to factor and solve your inequality as an equation in standard form. Okay, so if you have ax squared plus bx plus c equals 0, you're going to factor that left side. Okay, now once you get those solutions, the solutions are called your critical numbers. Okay, now your second step is you're going to place those critical numbers on a number line. Okay, so you're just going to draw out a number line and put whatever critical numbers you have on that number line. Okay, so your third step is you're going to pick random test values between your critical points. You can't pick your critical points as your test value, but you can pick the test values between the critical points and plug those values into your original equality or an equivalent. So if you factored your original inequality, you can use that if it's easier. Okay, and you want to plug it in to see if it's true. Okay, and if it's true, then it's part of your solution. Okay, now your fourth step is a 4a and a 4b situation. Of course, if you have less than or greater than in your original inequality, you're going to use parentheses. If you have less than or equal to or greater than or equal to, you're going to use brackets. Okay, now the part of your solution that has the negative infinity or positive infinity will always have the parentheses. So you could very well have a solution where half of it's in a parentheses and half of it's in a bracket. Alright, so if you are still writing, please feel free to press pause, but we're going to go ahead and go to our first example. Alright, let me bring that down. Okay, so let's say, for example, we wanted to solve x plus 3 times x minus 2 is less than 0. Alright, so to solve this one, remember, your first step is to factor and solve. This is already factored. So we're going to solve x plus 3 times x minus 2 equals 0. Okay, so we just set both of those to 0. So that means x plus 3 can equal 0, or x minus 2 can equal 0. So if we subtract 3 from both sides, we get x is equal to negative 3. Or we add 2 to both sides here, x can equal positive 2. Okay, and remember, those two are now your critical numbers. Alright, so once we get our critical numbers, we go ahead and go to our second step. Which means we put those critical numbers on a number line. Okay, so we go ahead and draw out our number line. And remember, that goes from negative infinity to positive infinity. So we have our -3, and our +2. Okay, so what I usually like to do is draw a little dotted line between the two and identify what values are in each section. So this section covers -infinity to -3, so any number all the way from -infinity and stops at -3. And since we have less than, we're going to put a parentheses there at -3. Okay. Now in between here, we have from -3 to -2. And again, we're using parentheses because of the less than. And this goes from 2 all the way to +infinity. So we just 2 all the way to +infinity. Okay. Now our third step is we pick a test value. Now in this section, the test value can be anything from -infinity to -3, but it can't equal -3. So I'll pick x equals -4. And in between here, you have -3. I put -2, and that should have been +2. All the way to +2. Whenever possible, just out of sheer convenience, try to pick x equals 0. And from here, from 2 to infinity, I'm going to pick x equals 3. Again, you can pick any number. These are just random values here. You could have picked x equals 1. You could have picked x equals 2.5. 1.5. It doesn't matter. All right. So we're going to go ahead and plug it into our original inequality. So instead of x plus 3, you're going to have -4 plus 3. Instead of x minus 2, you have -4 minus 2 is less than 0. So -4 plus 3 is -1. And -4 minus 2 is -6. Sorry about that. Alright, slide that up a little bit. -1 times -6 is +6, so that gives us 6 is less than 0, which is false. So we know that this -infinity to -3 is not in the solution set. Alright, so now we do the same thing with -3 to 2, where we pick x equals 0. Again, we plug in 0 for x here. So that gives us 0 plus 3 times 0 minus 2 is less than 0. 0 plus 3 is 3, so you have 3. 0 minus 2 is -2. So here we have -6 is less than 0, which is true. So it's part of solution set. Okay, so we don't cross that one out. Here we have x equals 3. So you have, instead of x plus 3, we have 3 plus 3. And instead of x minus 2, we have 3 minus 2 is less than 0. So they get 3 plus 3 is 6, so we have 6. 3 minus 2 is 1, so 6 times 1 is less than 0. That gives us 6 is less than 0, which is false. So again, we know that this is not part of the solution set. Okay, so the only section that's part of the solution set is from -3 to +2. Okay, so that gives us our solution. So our fourth step, which is, in some cases, they may want you to graph it. So if you're going to graph your solution, you just write your critical points, -3. Why am I so busy trying to put -3 to 2? And we know the point from -3 to 2 is part of the solution, and we're going to use parentheses. So we're going to use parentheses here also. So in between here, It's shaded in. So this represents the graph of your solution set. But your solution interval will be written as -3 to 2. Okay, this is just your graph. All right. Okay, so if you are still writing, please feel free to press pause. We're going to go ahead and go to our next example. All right, you bring that back down. There we go. Okay, so this example wants us to solve x squared plus 4x is greater than or equal to 5. Okay, so you have x squared plus 4x. We want to bring everything to the left, so we're going to subtract 5 from both sides. So if we subtract 5 from both sides, we have x squared plus 4x minus 5 is greater than or equal to 0. So remember, for our first step, we have to solve this as an equality. So we have to solve x squared plus 4x minus 5 equals 0. Okay, where again we just find two numbers that multiply to equal our c, and those same two numbers add to equal your b, which in this case 5 and -1 works. Okay, so that means x squared plus 4x minus 5 will become x plus 5 times x minus 1 equals 0. So if we set both of those to 0, that's x plus 5 equals 0, or x minus 1 equals 0. So if we subtract 5 from both sides, we have x equals -5. And if we add 1 to both sides here, we have x equals 1. Okay, so we now know our critical points. Okay, so that brings us to our second step, where we put them on a number line. Okay, so go ahead and draw our number line. Again, that's from -infinity to infinity. So we have -5 and 1. So we have -5. We have 1. Okay. Now, what we're going to do, which is why I'm going to, well, this is actually our third step, but we're going to factor this into x plus 5 times x minus 1 is greater than or equal to 0. Okay, so when we plug in our test values, we're going to use this. This is an equivalent of x squared plus 4x minus 5. It's just easier to plug in test values when it's already factored. Okay, so we're just going to use the equivalent of our original inequality. Okay, so we have our number line drawn, and again, just put our little dotted lines there. And this interval here, remember, that's from -infinity and -5. Remember, it's greater than or equal to, so our -5 is going to have a bracket. Okay, now here you have from -5 to 1. You have -5 to 1, and remember, it's greater than or equal to, so you will have the bracket. Alright, so here you have from 1 to infinity. So again, you have your bracket from 1 to infinity. And remember, your positive infinity and negative infinity will always have parentheses next to them. Even if everything else has a bracket, you'll always have parentheses near your infinities. All right. So now we go to our third step where we pick our test values. So from negative infinity to negative 5, I'll pick x equals negative 6. From negative 5 to 1, I'll pick x equals 0. And from 1 to infinity, I'll pick x equals 2. Okay. So we're going to go ahead and plug it into this one since it's an equivalent to our original. Okay, so instead of x plus 5, we're going to pick negative 6 plus 5. So negative 6 plus 5. Instead of x minus 1, be negative 6 minus 1 is greater than or equal to 0. So negative 6 plus 5, that gives us negative 1. Negative 6 minus 7, minus 1, that gives us negative 7, kind of jumping ahead there, is greater than or equal to 0. Negative 1 times negative 7 is greater than or equal to 0, which is true. Okay, so since it's true, we know that negative infinity to negative 5 is part of the solution. Okay, so let's try negative 5 to 1. Okay, we picked x equals 0, so we go ahead and plug it in. So we have 0 plus 5 times 0 minus 1 is greater than or equal to 0. 0 plus 5 is 5. 0 minus 1 is negative 1. So negative 5 is greater than or equal to 0 is false. So we know that this is not part of our solution. Okay, you can draw a line through, you can draw an X, doesn't matter. Okay, so you go from 1 to infinity, we picked x equals 2. So that gives us 2 plus 5, if we plug it into that one, times 2 minus 1 is greater than or equal to 0. Okay, now 2 plus 5 is 7, so we have 7. 2 minus 1 is 1, is greater than or equal to 0. So that gives us 7 is greater than or equal to 0, which is true. So we know that this is part of the solution. Okay, which brings us to our fourth step, where if you had to graph it, again, you'd make your number line, put your critical points on it. Okay, so we know from negative infinity to negative 5 is true. So that's negative infinity, that's positive infinity. And since you had a bracket here, you're going to have a bracket here also. So everything from negative infinity to negative 5 is true. So we're going to go ahead and shade that portion of it in. Okay, so we also know from 1 to infinity is part of the solution. So again, we get our bracket, and we go ahead and we shade it in. Okay, now that's our graph of the solution set, but our actual solution written in interval notation, it's from negative infinity to negative 5, or you can pick it from 1 to positive infinity. And once again, I forgot my bracket here. There we go. Okay, so that would be your solution interval. That little kind of looks like a rounded U. That's kind of your OR. All right. Okay, so if you are still writing, please feel free to press pause, but we're going to go ahead and go to our next example. Okay, bring that down. Okay, so we have 2x squared plus 4x plus 9 is less than 0. Alright. Okay, so we know for our first step, we have to factor and solve the standard equation. So that's 2x squared plus 4x plus 9 equals 0. Okay, and you can use the A times C method. You can use whatever method you want. Personally, I'll just use the quadratic formula, where x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we see here a is equal to 2, b is equal to 4, and c is equal to 9. Let me kind of separate that a little bit so you can see those. Okay, so if we go ahead and plug everything in, we know x is equal to negative b, so that's negative 4, plus or minus the square root of b squared, so that's 4 squared, minus 4 times a times c all over 2a, which is 2 times 2. Okay, so if we go ahead and start simplifying things, we have x equals negative 4 plus or minus the square root, 4 squared is 16, minus 4 times 2 is 8, 8 times 9 is 72, all over 2 times 2, which is 4. Okay, so that gives us x equals negative 4 plus or minus the square root of negative 56 over 4. Alright, so what we're going to do here, we have to remember square root of negative 56 is equal to square root of 56i. Okay, so we know 56, to get a perfect square factor, we can make that equal to square root, put that up underneath there, which is incorrect to do. There we go. So we have 4 times 14i. Okay, so we can separate those to square root of 4 times square root of 14. So square root of 4 is 2. Square root of 14i. Okay, so this gives us x equals, if we separate those two, we have negative 4 over 4 plus or minus, instead of square root of negative 56, we have 2 square root of 14 over 4i. So if we simplify those, it really just gives us x equals negative 1 plus or minus square root of 14 over 2i. Alright. Now, the one thing we can tell here is you have a complex solution, but because you have a positive a value, we know that the parabola opens up on the graph. So what we're going to do is draw a quick graph of what that would mean. Okay, so if you have all your x values, your graph will look something like that above your, move that up some, above your x-axis. Okay, so the fact that you have a complex solution means that this graph does not cross the x-axis at all. So since we have a complex solution. We know the parabola, which is just the drawing of a quadratic graph, does not intercept the x-axis. So in this case, there's no real solution. Okay, so you might not encounter a problem like that, but this is it just in case. Okay, now the thing is, if you have 2x squared plus 4x plus 9 is greater than 0, then every value would be a solution, because all of these values would be greater than 0. Alright, so let's go ahead to our next example. Let me move this down here. Let me go ahead and straighten up my papers. There we go. Okay, so what if we wanted to solve 2x squared minus 10x plus 12 is greater than 0? Okay, so what I want you to do, move that over, is I want you to go ahead and press pause, and I want you to solve this one on your own. Alright, so I'm assuming that you have already pressed pause and worked this one out. So let's go ahead and verify your solution. And please excuse the shadow. The sun decided to move a little bit. Okay, now quick hint before we start our steps. You have 2x squared minus 10x plus 12 is not greater than equal to, just greater than, is greater than 0. Okay, so if you notice, all of these terms are even. So you divide each term by 2. 2 divided by 2 is 1, so you have x squared minus 5x plus 6 is greater than 0 divided by 2, which is 0. Okay, so it kind of takes away the need to use the quadratic formula or the A times C method. Okay, so instead of working with this one, we can work with this one. Okay, so that brings us to our first step, where we factor the equation. So we have x squared minus 5x plus 6 equals 0. So we find two numbers that multiply to equal your c, and those same two numbers add to equal your b. Okay, so in this case, -2 and -3 works, because -2 times -3 is positive 6, and -2 plus -3 is -5. So this factors to become x minus 2 times x minus 3 equals 0. So we have x minus 2 equals 0, or x minus 3 equals 0. So we add 2 to both sides, and we add 3 to both sides. Okay, which gives us our critical points, or critical numbers. Alright, so again, if you use a quadratic formula or anything else, you just get the same critical numbers. This was just a little bit of a shortcut that you might want to notice. Okay, so that brings us to our second step, which is drawing it on the number line. Okay. So we have 2 and we have a 3. And again, that goes from negative infinity to infinity. So just drawing the little separator here. Actually, I can move this over some, give me a little more room. From 2 to 3. There we go. Okay, so this is from negative infinity to 2. And remember, it's greater than, so we're going to use parentheses. This is from 2 to 3. And this is from 3 to infinity. Okay, so we bring us to our third step where we pick values. So from negative infinity to 2, we're going to pick x equals 0. From 2 to 3, we're going to pick x equals 2.5 or 2.5. And from 3 to infinity, we're going to pick x equals 4 as our test value. Okay, so if we plug it in, and remember here, we can plug it into this one, or we can plug it into x minus 2 times x minus 3 is greater than 0, because it's equivalent. All it is the factored version of that. So again, usually it's just easier if you plug it into the factored version. Alright, so if we plug in x equals 0, that's 0 minus 2 times 0 minus 3 is greater than 0. 0 minus 2 is negative 2, so you have negative 2. 0 minus 3 is negative 3. So that gives us 6 is greater than 0, which is true. So this part of the solution. Okay. Now this, picking x equals 2.5, I'm going to show you a little different way if you don't want to be bothered with the adding and subtracting of decimal numbers. If we plug that in, 2.5 minus 2 times 2.5 minus 3 is greater than 0. Okay, so here we can see that 2.5 is bigger than 2. So 2.5 minus 2 will give us a positive number. Okay, so here we see 2.5 is smaller than 3, so 2.5 minus 3 will give us a negative number. So a positive number times a negative number will give you a negative number. So you have a negative number is greater than 0, which is false. Okay, so that's kind of a little shortcut if you end up with a decimal and you don't feel like doing all of that. That's false, so we know that that's not part of the solution. Okay, so here we pick x equals 4. So you have 4 minus 2 times 4 minus 3 is greater than 0. Okay, so if we simplify that, 4 minus 2 is 2. 4 minus 3 is 1. So that gives us 2 is greater than 0, which is true. So this is part of the solution. Alright, so brings us to our fourth step, which is putting all of this together. So if we were going to graph our solution, putting down our critical points from negative infinity to infinity. We know from negative infinity to 2 is part of the solution, so we put our parentheses. And from negative infinity to 2. And we know from 3 to infinity is part of the solution. So we go ahead and shade that in. That's our graph. But our solution interval would be from negative infinity. Why do I keep trying to put a negative 2 there and it's not negative 2? Negative infinity to 2, or from 3 to infinity. Okay, so that would be your solution interval. Alright. So hopefully this made sense, and I will see you on the next video.